Okay, here is where we left off on the subtraction notes. So if you're back to page 41, we're going to talk about the subtraction of angles. So much like we did here for segments, where we had two separate segments and then we had the whole big segments congruent and then pieces of them congruent, we took the big segment minus the little segments and found that the remaining two pieces then would have to be congruent. So let's draw a similar picture. Let's draw two angles. Let's divide them each into parts. I'm going to label this A, B, C, vertex D, and then let's go E, F, G, vertex H. All right, so much like we had for segments, I'm going to say the whole big angle here is congruent to the whole big angle here. So that would be angle ADC congruent to angle EHG. And then I'm going to say this little angle, angle ADB, is congruent to this little angle, angle EHF. And then by subtraction, I'm going to say that angle BDC must be congruent to angle FHG. I'm taking congruent angles and I'm subtracting congruent angles, so the two remaining parts, these two that are blank, must be congruent. So much like we wrote in the first box, except we're going to use angles. If congruent angles are subtracted from congruent angles, then the differences are congruent. These differences being these two blank pieces right here. We can do the same idea. Instead of talking about congruent angles being subtracted, we could talk about the same angle being subtracted. Much like in this diagram up here, we had two segments that shared segment BC, so we removed BC from both of those, and we were left with AB congruent to CD. So down here, draw yourselves a big angle, and then let's cut two little pieces off on the side. Let's say this big angle right here is congruent to this big angle right here. Let's label this A, B, C, D, and E. So I'm starting with saying that angle AEC is congruent to angle BED. Now you can see that both of those angles that I marked, both of them share this middle angle BEC. So if I subtract that same angle from both of them, hopefully you can see the two pieces I'm left with are angle AEB and angle CED. Again, I'm going to take these two big angles, AEC and BED, right? I can see that they both contain this middle section. So if I subtract that middle section from both, I'm left with angle AEB congruent to angle CED. And it'll read, if the same angle is subtracted from congruent angles, then the differences from those subtractions are congruent. So let's take a look at the angle problems. We did the segment ones in class. Let's mark what we have here. Angle ABD. So trace it. ABD is this big angle. I mark it with the big arc there. And that matches angle EDB. That's this big angle right here. Make sure you can recognize those angles properly. That's this one. Okay. Then in purple, I'm going to mark this next one, CBD. CBD. So that's this angle right here. I'm going to put a little single mark on that one. Congruent to CDB, that's this angle. So I'm going to mark that opening. So I've checked those off. All right, hopefully, right, if you read right above it in diagrams, look for segments or angles that are overlapping. So hopefully you can see that this big angle overlaps with this little one, and that this big angle overlaps with this little one. When you have overlapping, you're going to subtract. You're going to take the big angle right here, the one that's marked in black, and I'm going to remove the one that I marked in purple. I'm going to subtract. And so you can see what angle is left. That's angle ABC. So let's mark that down. Angle ABC, congruent to, again, I took the big angle, this one right here, and I removed the purple one. I'm going to hide it. That's why I was left with angle ABC. Now I'm going to do the same thing on the other side. I'm going to take this big angle right here and I'm going to remove this overlap. So this purple is the overlap. That leaves me with angle EDC. Those would be the two pieces that are left congruent. I took the big congruent angles and I subtracted the purple angles from each one of them to be left with ABC and EDC. All right, let's try it on the one below. Okay, so right here, let's mark what we have, angle CDB. Mark it carefully, CDB. So if I mark that opening, that's this one right here, is congruent to angle, I'll mark this one in purple, ADE. Right? So that's, if I mark that opening, that's this one. Those two are congruent, so I give them the same marks. Again, if you remember, we're looking for, in subtraction, we're looking for overlap. You should see that these two congruent angles overlap right here. They both have this middle angle. So if I block out or subtract that middle angle from both of them, right, take that out, which ones am I left with? I'm left with angle ADC, and that will be congruent to the one that's left over here out of the purple, which is angle BDE. So I'm subtracting whatever's overlapping, I'm subtracting that from both. So I have this black one and this purple one that overlapped right here in this middle section. This was where the overlap was, and I subtracted that out of both to be left with these two angles. Okay, let's see how we can use this in some proofs. So go ahead and let's flip the page. And let's look at these two proofs. Example 2, let's mark down the given. Angle NOP congruent to angle NPO, and angle ROP congruent to angle RPO. Again, carefully mark these on your diagrams. If you mark them wrong, it's going to mess up your thought process here. Angle NOP, that's this big angle, so I'm going to mark that in black right here. Congruent to angle NPO, that's the big angle over here. That's the first one. The second one is angle ROP, that's this lower one right here. I'm going to mark the congruence. And angle RPO is this bottom one down here. Okay, now I've marked the congruences. Immediately when I look at this diagram, I should see that there is overlap. I have this big angle that overlaps with this, and I have this big angle that overlaps with this. So when I have overlap, I subtract. So from this big angle, if I remove the overlap, I'm left with right here, I'm left with angle NOR. All right, I had this big angle and I subtracted that overlap. Now I have this big angle and I'm going to subtract this overlap. That's going to leave me with angle NPR. Again, I took the big angle, removed that overlap. I took this big angle and I removed the overlap. So I have if congruent angles, these two right here, are subtracted from congruent angles, those are the big ones that I'm subtracting from, then the results, which are the differences, are congruent. And that is exactly what I was trying to prove. Okay, let's move down to the third example here. I have angle ADE is supplementary to angle DAB. I have angle BED is supplementary to angle EBA. Then I have angle ADE congruent to angle BED. And I have angle CAB congruent to angle CBA. That is a lot of given. So, ding, 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 I have the two supplementary statements, which is looking good, right? I'm going to mark these in the diagram. Angle ADE, that's this whole angle right here. Angle BED is this big angle right here. Again, make sure you're labeling them properly and picking them out properly. Then I have angle CAB, if I trace it, that's this little guy up on top, and CBA is this little guy on top. So I've marked all the given, but I'm very intrigued by what I have in the box because I know from my previous lesson if I have two angles that are the same, right, or congruent, I can get the other matching pair. And I look right below and I see ADE and BED. I see these two. So I know I can definitely build off of that given, and I can say that angle DAB, which is this guy, is congruent to the one that's left here, angle EBA. And that's by the previous lesson. That's if angles sup to congruent angles, then they are congruent. All right, so now let's mark that in the diagram. Where is that? Angle DAB. I'm going to mark that in purple. DAB is this whole big angle right here. And angle EBA is this whole outside angle. I'm going to mark that matching. Well, now again, this is very visual. Now when you're looking at your diagram, you should see overlap here. I see a purple angle that overlaps with this black angle, and I have this purple angle that overlaps with this black angle. So because I have the overlap, I can subtract. Remember, you subtract the overlap. So start here, cover up the overlap, which is this part right here, and what angle am I left with? DAC, or you could call it DAE, whatever you like. I'll call it DAE. And then on the other side, I have the purple that overlaps with the black, so I'm going to cover up the overlap, and I can see it's this angle that's left, which is angle EBC, or I could call angle EBD. Doesn't really matter. And that's by subtracting. So that's if congruent angles are subtracted from congruent angles, then the differences are congruent. I think we have what we need because angle CAD is the same as my DAE. So these are the same angles. I just named it differently. And let's see, CBE is the same as what I called EBD. So those are actually the same. So I have finished the proof. I just have them named slightly differently. I'm going to go back and do one other problem. If you want to see me go back and do this example 2 from page 40, I'll show you this one quick. We have AC bisects WY. So if it bisects this segment, it cuts WY in half. So these two little segments would be congruent. W and Y, this point and this point, trisect this big segment XZ. So that means this segment is congruent to this segment is congruent to this segment. All right. I also have the fact that XW, this guy right here, is 4x minus 10. I know that WY, this segment, is 2x. And YZ is 25 minus 3x. All right, so I know these three segments are all the same, so I think I would start there. I can take any two of these expressions and set them equal to each other because I know they're all the same. So I'm just going to do the first two. 4x minus 10 is 2x. If I solve, I get negative 10 equals negative 2x, and divide, I get x to be 5. So if I plug 5 in, I can get some lengths of segments right here. 5 times 4 is 20. 20 minus 10 is 10. 5 times 2 is 10. And 5 times 3 is 15. 25 minus 15 is 10, which we know to be true since it was trisected. They should all come out to be the same. The question is, though, it wants xb. So it wants to know how far it is from here to here, right? Which is, well, here in the middle, from here to here. So I know this part is 10, but I don't know how far this part is, but I do because I know from here to here is 10, but these two pieces are the same, so each one should be 5, which makes that whole distance 15. And there's that final example.